Okay, here is the results video for Lab 25 for microbiology. I'm here on Friday, April 10th, Good Friday. It's my mistake that I'm here. Should have been a Monday, Wednesday lab this week instead of a Wednesday, Friday. But what we have are our 5 antibiotic discs. And so what you want to do is on page 205 of your laboratory book, you want to write down each antimicrobial agent. The first antimicrobial agent is bacitracin. And the disc code for bacitracin is B like boy 10. The second one is tetracycline, and the disc code is TE, like T like Tom, E 30. The third agent is streptomycin, and streptomycin's code is S10. Then the fourth antimicrobial agent is chloramphenicol, and chloramphenicol is C30. I feel like I'm playing bingo. Okay, and then the fifth antibiotic disc is penicillin, and that is P like Paul 10. Okay, so you want to put those down as your antimicrobial agents and your disc codes. And the first bacteria that we're going to look at, we're going to measure the zones of inhibition for these Petri dishes. And I will first just briefly show you how they turned out. Okay, you can see pretty much the zones of inhibition there. It's a little bit more difficult to see. Maybe if I get a little lower light, you can see the different zones of inhibition there. It's a little more, a little easier to see on E. coli. But for each antimicrobial agent, I'll call out what the zone of inhibition was using my trusty dusty ruler. Okay. So for bacitracin, our zone of inhibition is, and these are measured in millimeters. So your zone size for bacitracin is 19 millimeters. Your zone size for tetracycline is very small. It grew right up to the disc, is 7 millimeters. Your zone size for the next antibiotic disc, streptomycin, a little larger, 17 millimeters. Your zone of inhibition for chloramphenicol, look at this in the white. No, white background doesn't help very much. Zone of inhibition for chloramphenicol is 30 millimeters. And then finally, your zone of inhibition for penicillin, much smaller, is 10 millimeters. Okay, so 10 millimeters. So make sure that you write down those zones of inhibition in your laboratory book. We'll worry about S, I, and R in just a minute. The next bacteria that we're going to look at is E. coli, and you can see more readily the zones of inhibition here. Okay, there you can see that there is less microbial growth, and there's just an inhibited area where there's no microbial growth around the antibiotic discs. So let's go ahead and do these. For bacitracin, the zone of inhibition is 6 millimeters. For tetracycline, the zone of inhibition is 21 millimeters. For streptomycin, the zone of inhibition is 13 millimeters. For chloramphenicol, the zone of inhibition is 23 millimeters. And for penicillin, the zone of inhibition is 6 millimeters. Okay, so make sure you've got those written down. And then finally, Pseudomonas aeruginosa. One of the things you'll see with Pseudomonas aeruginosa is the bacteria basically grew right up to the antibiotic disc, so there was little or no inhibition. In that particular case, when the bacteria grows up to the disc, then the zone of inhibition is merely just the diameter of the disc itself. Okay, so for these, the first one is bacitracin, and the zone of inhibition is 6 millimeters. Next one is tetracycline, and the zone of inhibition is 6 millimeters. The third one is streptomycin, and the zone of inhibition is 9 millimeters. The third one is chloramphenicol, and the zone of inhibition is 7 millimeters. And then finally, penicillin, which had a zone of inhibition of 6 millimeters. Okay, so not much inhibition there at all. Mostly the Pseudomonas aeruginosa was resistant to the antibiotics, so it grew right up to the antibiotic disc. Now, on your laboratory results, it also asks you to state whether the zone of inhibition denotes that the bacteria is susceptible, intermediate, or resistant. So you have to rate them SIR, and then tabulated on page 203 of your laboratory book are all of the different antibiotics. Okay, so we have chloramphenicol, we're missing some of the antibiotic discs here. So what I think I'm gonna do, ooh, this is really, really bugging me, okay. What I'll do is I will post a spreadsheet here because chloramphenicol, they give results. Tetracycline is given results only for Staphylococcus, which would work for Staphylococcus epidermidis. And tetracycline, when testing Enterobacteriaceae, which would be E. coli. Then penicillin with Staphylococcus and Enterococcus, but you're missing some vital information. So what I'll go ahead and do, there's nothing for bacitracin on here. And there is nothing, let's see, I have penicillin, I have streptomycin, I have chloramphenicol, so there are data missing here. So I will go ahead and give you a separate sheet. I'll go ahead and post that on Moodle next week so you can finish off your results for the zones of inhibition. And I do apologize for that. We have antibiotics and we have bacteria that aren't necessarily listed in our book. Okay, so at least you've got the first part here. That will conclude our video lab for lab 25. And next week, I will be doing lab 45 only. That's a change. We were gonna do 45 and 46, but next week I'll do lab 45 only. And then when we do that lab, I'll give you critical thinking and clinical applications for lab 25. And that's it. Happy Easter.